First lesson of Pre-Calc B, and it's not just a little cream puff lesson, so let's go. Good news is it piggybacks something you're supposed to be pretty efficient at, but let's make sure you're good. And this lesson's going to piggyback this, so it's a little bit of a review with a twist. I'll explain the twist in a minute. This is the review. So we know that from A, we got the amplitude is absolute value of A. If B is something other than 1, then we're going to need the formula plus or minus C over B to determine phase shift. You can see your C's right here. Now, when I teach this, I eliminate that plus or minus as part of the formula because if this is plus, it's left. If it's minus, it's right. It's just your basic rules of transformations. So, we just explained this. And then D is up D if it's positive, down D if D is negative. So with all that being said, let's just start with our most foundational, I would call this a parent function by this time. We know that it goes right through the origin like this. That's at least how I taught this lesson in Pre-Calc A. And then we know that it goes up to 1, back to 0. This goes down to -1, back to 0. Now that's one period, and I could keep going, but we're just going to really concentrate on one period just to kind of get the point made here, just so our drawing doesn't get crazy. So what does this 2 do? Well, that 2 is our A, so the absolute value of 2 is just 2. So we know our amplitude originally is 1 because there's an invisible 1 right here, and it all makes sense, but now we've got to double our amplitude. So these zeros, if you double 0, what do you get? 0. So that doesn't change. Those are kind of like our anchor points. But here, -1, not a perfect drawing, but goes down to -2. +1 goes up to +2. So now I'm going to dot this. Well, I can go ahead and make it solid. And I'm trying to stay color coordinated here. So now let's go over to the green graph here. What's the difference? Well, the 2 is the same as the 2, so we have the same amplitude as the red one. But here you can see B is 1, which it's not always going to be 1, and that's going to mess with us a little bit. But because it is, this is a simpler problem, because here's my C. That means I need to go right pi over 2. Well, what's pi over 2? It's just a chunk. So I'm going to take my anchor points, which is here, 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 and here. Everything needs to go over one chunk. So this comes to here, this comes to here, this comes to here, so I can see part of it. And so now this comes to here, this comes to here, and I can see the other half. So really what we do, we move the red one, right one. It makes sense once you visualize it, once you get it drawn in, but sometimes people struggle with that. So that's part 1. Let me add something. Okay, so here's a little different look. And I'm going to explain this. This is what we're used to. Now they're going to introduce you to this, and then they're going to throw this function terminology at you. Don't panic. H of x, g of x, L of x, doesn't matter. It's just a substitution for y, so don't let that throw you. But now we've got this business. So my A is 1. I'm not concerned about that. My K, which is my D, is 0 because there is nothing over here. You can notice my C has been changed to H. Not a big deal. They're just the same thing. So if I was to just start this and if I was to give it to you and say, hey, try it, I bet you guys would think to distribute this, and then you would rewrite it as sine of 3x minus 3 pi over 2. And that's not wrong. I mean, that's basic math 101. You distribute through parentheses. So now let's take a look at it if we actually follow our rules. So what's our amplitude? 1. Is this going to be moved up or down later? No, because there's no D or K. Here's my B. Here's my C. Now remember, negative means to the right ultimately. So I'm going to ignore that in my formula C over B. So my C is 3 pi all over 2. That's my C, or my H. all over b, which is 3. Now, I'm just going to go ahead and teach you a little something, something. 10 over 2 over 5. Now, we know 10 over 2 is 5, so 5 divided by 5 is 1. Why am I showing this to you? Because we have a situation here. You've got to know what to do. Let's experiment and let that denominator of the numerator fraction slide underneath that line and multiply. When do we get 10 over 10, which is still 1, which says that's a good move. So I'm going to have this thing jump over that line, multiply, so I get 3 pi all over 6. And if I reduce that, I get pi over 2, which if you take a look at the original, and if I only concentrated in here, if I ignored that 3 for just a second, your old rules apply. That would be right pi over 2. And notice we went through the process of distributing the 3, put it in the formula, and we still get right pi over 2. So my point is, if it's written like this, you can concentrate here and just say, you know what, all that's doing is it's just moving it right pi over 2. So let's go ahead and do that. I'm going to do it to the best of my ability. Right there. This moves here. This moves here. So that goes here. All right. Let me pause this and add something. Give me a second. So essentially what they're doing is they're giving us a different look and just seeing if we can hang and kind of understand our rules. So they're building, giving us different looks. So look at this green one here. And I want you to compare the green one to that red one. Notice this is a parentheses, and inside the parentheses it's like we've got a distribution situation there. But then I just concluded, you know what? If it's written like this, you can kind of ignore that 3, because if you distribute it, you're going to get the same thing. So that's just straight up right pi over 2. Now look at the subtle difference here. It's very subtle. They look very similar. But if you're thinking, oh, I'm just going to go right pi over 2, that's where you're going to make a mistake. Because notice, now this is my B, this is my C. Notice my B over here was really a 1. That's the key. Yes, there's this 3 sitting there, just almost there to confuse you. But now let's take a look at this. If we followed our rule, and we go C over B, that'd be pi over 2. Notice I'm ignoring the negative, because I know that means right. But let's finish the formula. So pi over 2, all over 3, C over B. Remember what I just said? That can jump underneath there. So that's now pi over 6. So what that means is, I'm going to get rid of this because our parent function is the black one. I just don't want so many lines you get confused. We need to take our parent function, which is y equals sine of x, right here, make our adjustment. That means we got to go right, because of the negative, pi over 6. Well, it's kind of difficult because pi over 6 is 30 degrees. Pi over 2 is 90, so it's a third of a unit-ish. So we need to move right a third of a unit. So that's going to go right about there-ish. That, which is supposed to be up here, is going to move a third of the unit here. This will move a third. This will move a third. This will move a third-ish. And then we connect the dots. So it didn't move far. It moved pi over 6, which is 30 degrees, which is just a smidge. So there's a little different look. Okay, so now we're going to really try to focus on this concept, the period of these sinusoids, which is sine, cosine, tangent, what have you. But we're focusing on sine. And all these rules apply to cosine, all these rules apply to tangent. But let's focus on sine just to get the point made. So, start with our parent function. By now you should just have this kind of memorized. And I'm going to focus on one cycle, or one period. And as you can see, I'm going to make a wall here, and I'm going to make a wall here. Don't forget, this thing just keeps going and going and going, but we're going to focus on one period. So this is pi from there to there. This is negative pi, but it's still pi, making our total period 2 pi. Now notice, the formula given to us, period, 2 pi. Now, don't make light of that. That's like spoon feeding you the normal period of our parent function. And we see that it's 2 pi. We can just see it. Now with that in mind, we know our formula is right here. So let's take a look at this b. That's a 1. So what's 2 pi over the absolute value of 1? Well, that's just 2 pi over 1, which is just 2 pi, which is like, aha, the formula works. So let's apply it to this blue one. Here's my b. Now this is going to change. So 2 pi all over 2. Now stop and use your noggin. What are we doing to the original period? We're dividing by 2. We're cutting it in half. So if I was to say, what is the new period? The new period is pi. What do we do to it? We cut it in half. So that means it's going to complete one cycle in pi units. So this is 2 pi. So how do we have pi? Well, my brain says if I go to the right, pi over 2, and if I go left, pi over 2, that's pi. So I got to bring these walls in to here and to here and duplicate this. So it's a horizontal shrink. So this moves here, this moves here, this moves here, this moves here, and you can see now, here we go, boom. So there, it's horizontally shrunk. Now, the thing I'm trying to say is, if we kept going, we have one cycle in half the time. So that means this blue function would have 2 cycles, in 2 pi. Because the original period was cut in half, we could draw 2 of these in 2 pi now, because we cut it in half. So now they're kind of like, all right, how many cycles can you put in the normal period? And you'd say, oh, 2. I can fit 2 of these in this space. Now, this would continue, for example, this would continue like this, and this would continue like this. So we have a cycle here, and we have a cycle here. So now we have 2 cycles in the normal period. So they're going to come at you with a little different language. Now, let's try to focus on this green one. Let me get rid of this blue. I think that's just going to confuse us a little bit. I'll keep it there. All right. So let's focus on this green. So what's the formula? 2 pi from that. All of the absolute value of that, which is just 1/2. Now what happens when you divide by a fraction? Well, you multiply it by the reciprocal. So that's times 2, which is 4 pi. Now, here's the thing. We are horizontally stretching the original. So remember, this is 2 pi. In other words, we have pi on this side, pi on that side. Well, now our new period is 4 pi. So we need 2 chunks of 2 pi. So this black wall gets extended to here, because now this is 2 pi. And then this black wall gets extended to here, which is negative 2 pi. So that's 2 pi plus 2 pi. Let me get rid of these walls from the blue, just a distraction. And now we've got to horizontally stretch this thing. So this, in the original parent function, goes up and down in that window. So it needs to do the same thing here. So it stretches. The halfway point would be pi. It goes up and down, but it got stretched. This one goes underneath the x-axis, goes down and up in pi. It needs to do the same thing in 2 pi. So now we have a horizontal stretch. Now here's the twist on the language. How many cycles can we fit in the original period? We can only fit a half of a cycle in the original period because we stretched the whole, we doubled the period. So in the normal period, we only got half of our drawing, if that makes sense. So they're going to come at you with that language. It's a little confusing, but be prepared to discuss it. All right, so I'm going to end this part 1 lesson video right now. So if you like the video, like and subscribe. Thank you, Ryan Shepard, for helping me become famous.